So good morning to all of you MSc Physics first year student. So today again welcome to lecture series in quantum mechanics, and we want to continue our chapter is the angular momentum. And today we want to start the new point, that is the general theory of the spin. In the last lecture or summary of the last lecture, we have to see here the Stern-Gerlach experiment, which is given the experimental evidence of the spin, and we have to know that idea, the spin, which is consider the value of the spin, that S, okay, spin which is denoted by capital S, and the value of the spin which is considered as S is equal to plus or minus half. Okay, so that is nothing but the plus half is nothing but the spin up, okay, which is spin up, and minus half is nothing but the spin down. Okay, because of you have to know that beam of silver atoms which is passed through the in non-uniform magnetic field or inhomogeneous magnetic field, so that beam is split into two components, that is spin up and spin down, and that is nothing but this component is nothing but the spin hub, that is plus half, and spin down, that is the minus half. Okay, and this spin theory which is identical to the general theory of the angular momentum, and the total angular momentum which is denoted by capital J, and that such as same represented as your spin which is denoted by the capital S. Okay, and that component of S which is denoted by Sx, Sy cap, Sz cap, that generally we have to know already the component of the orbital angular momentum, so that is the Lx, Ly, Lz, component of the total angular momentum which is Jx, Jy, Jz, and such as this spin, the components of the S is the Sx cap, Sy cap, and Sz cap, and same the commutation relation which is as the angular momentum and total angular momentum. So that is the component of the component of the S bar. Okay, the component of the S bar is which is given by Sx cap, Sy cap, and Sz of cap. Okay, so this is the component of the spin, and the commutation relation which is similarly that orbital angular momentum and total angular momentum. So what is, so that the relation, so that is the commutation relation which is given by, okay, and this relation is nothing but, for example, the first commutation relation which is Sx cap comma Sy cap, that is the commutator of Sx and Sy, which is nothing but the IH cross of Sz cap. Okay, so this is the first commutation relation. Next commutation relation which is nothing but the Sy cap comma Sz cap, which is nothing but IH cross of Sx cap. Okay, and next commutation relation which is given here, so that is the Sz of cap comma Sy cap, which is nothing but the IH cross of Sy cap. Okay, so this is the general commutation relation, and reverse of this that get here the minus IH cross sign. Again, if we want to see the addition of the S square and Hz commute, hence they have the common eigenvector, and the common eigenvector of the given here. So the addition of the S bar square and Sz, okay, and Sz which is commute. Okay, commute, hence they have common eigenvector. Hence they have common eigenvector. Okay, so if we want to represent of this s square, so this s square is nothing but of operates on that spin and azimuthal quantum number of the spin, or which is considered as the that value of ms. Okay, and this is nothing but the h cross square s into s plus 1. Okay, of ket of s comma ms. Okay, and similarly the eigenvector of sz. Okay, and this is given by s comma ms, which is nothing but the h cross of ms of s comma of ms. Okay, so this ms value, okay, if we have to know that, okay, so that the s is nothing but the spin angular momentum. Okay, s is nothing but the spin angular momentum. Okay, so that ms value, which is nothing but, and this s is equal to half. Okay, and this ms value, which is nothing but the minus s. Okay, minus s plus 1 up to s minus 1 and s. Okay, this is the ms value. Okay, so we want to see next point. So we want to calculate the spin or eigenvector or eigenvalue of s plus and s minus. So what is the formula is here, we want to see here. So first of all we want to write the formula of the s plus. Okay, that is the spin rising operator. Okay, or that notice here, so rising operator of spin, rising operator of spin. So this formula of eigenvector, which is given by s plus of s comma ms, is nothing but h cross into under root of s into s plus 1 minus ms into ms plus 1, and in ket value s comma ms. Okay, and we want to write down the lowering operator of the spin, lowering operator of the spin. Okay, and this is nothing but the s cap of minus of s comma ms is nothing but the h cross into under root of s into s plus 1 minus ms into ms minus 1. Okay, and in bracket ket vector of s comma ms. Okay, so this is the formula of the lowering operator of the spin. Okay, and if we want to calculate the s plus or s minus, so how it is calculate? Okay, so that we want to see here. So s plus or minus formula, which is given by, so this is the general formula total. So s plus or minus, which is given by sx cap plus or minus I sy of cap. Okay, and if we see what is the eigenvalue of sx square and s minus square, so first of all we have to know that what is the formula of Sx and S minus. So this Sx is nothing but, okay, Sx cap is nothing but the S plus S minus divided by 2, okay, and Sy cap is nothing but the S plus minus S minus divided by twice I, okay. So this is the general formula of the operator of Sx and Sy cap, okay. Again we want to see here what is the eigenvalue and eigenvalue of Sx square and Sy square. These are the similar as equivalent to that the orbital momentum or total angular momentum eigenvalue we have to calculate already. So I want to write down here directly. So this is nothing but the Sx cap square, okay, is equal to Sy cap square, and this is nothing but half of expectation value of Sx square and S square minus 8j square, okay. So expectation value of S square minus expectation value of Lz square, okay. So this is the formula, and we want to solve off this formula. So direct we have to get expression, so that is the h cross square by 2. This formula is nothing but the h cross by 2 into s plus 1 minus ms square, okay. And this is the eigenvalue of Sx square, or is equal to Sy square is equal to, so both of Sx square and Sy square, that eigenvalue formula is same, which is the h cross square by 2 s into s plus 1 minus ms square, okay. And one of the formula, the spin state form an orthonormal and complete basis. This relation we want to see, and next point we want to see in the next lecture. So where a cap denotes, okay, where expectation of a cap which denotes SMS, which is a cap is operate on again spin, and third component of spin, that is nothing but the ms value. So this value is given, so that as with this, the spin state form n, the spin states, the spin state form an orthonormal and complete basis, okay. And this orthonormal and complete basis, this relation which gives here, okay, this relation which gives here. So m prime ms prime, okay, orthonormal and complete basis, okay, which is given as s prime ms prime of s ms, and this relation gives delta of s prime ms prime, delta of s prime s, and delta of ms prime ms, okay. and given for this relation, so we have to given the identity matrix and this relation which gives the summation over, okay, ms is equal to, or the value of s ms is equal to minus s2 plus s minus s2 plus s, the ket vector of s comma ms and bra of s comma ms, and this is nothing but the identity matrix. This is nothing but the identity matrix, okay. And we want to see the general idea of the spin particle ms value and the eigen state of this. See, and in the next lecture we want to see the Pauli matrices. So first of all, okay, so what is the value of spin? So that spin half particle, okay, for spin half particle, for spin half particle, okay, so s is equal to half, okay, and ms value is equal to plus or minus half, okay. And if we want to see, so what is the relation of s and ms, so that value which is given here, so that is the half plus half and half minus half, okay, half comma plus half and half comma minus half, okay. And depending on this eigenstate and spin value, in the next lecture we want to calculate the Pauli matrices of sx, sy, s plus, s minus, s square, sz cap, and so on, and what is the this Pauli matrix relation or matrix representation of spin angular momentum. So this point we will be seeing in the next lecture. So thanking of you.